Hi everybody. Welcome to it's day 5, I guess, of our iOS 101 course. I'm excited to be back after like 5 days off. And there are a couple things before we start that I want to talk about. We're going to talk about strings in Swift today. Strings are really important. You'll use them in every program you ever write. But before we get to that, I just want to talk a little bit about something that we're going to try tomorrow that's going to be sort of an experiment. We noticed that last week, as we started the course, one of the things that didn't go so well is just trying to get everybody onto Slack and into groups, and coordinating between Slack and YouTube was a lot of trouble. So we're going to try something new tomorrow. We're going to use Zoom, which you're already using. You should already be using if you're watching the live lectures for your PM, your small group discussions in the third hour. We're going to actually use Zoom to broadcast the lesson and also to do discussion. So we're going to try switching over from Slack. This is sort of an experiment. We're just going to try it tomorrow. You will still be able to watch the lecture itself on YouTube. So we will still be streaming through YouTube. We'll just be doing discussion on on Zoom instead of Slack. There will be a link in the iOS June 11 channel that you can use to sign up. But this is the really important part. You actually, if you're going to watch on Zoom and be part of the discussion and everything, you need to sign up for the Zoom webinar. And so watch for a link to that and make sure you don't miss it. We'll announce it a couple more times before tomorrow night. Okay, so the second thing I wanted to talk about is just to share a little bit about Lambda School and our full-time course. A few of you have reached out to me with questions about it. You're interested in it. So I wanted to talk just a little bit about what sort of a day in the life. I've talked a little bit about it before, but I want to talk about sort of a day in the life of a Lambda School student, and how our full-time course works. So as I think I mentioned before, our full-time course is 30 weeks, which is just about 7 months full-time. You don't pay anything unless you get a job, and the way you pay is we take a percentage of your salary, but only if you get a job using the skills you learned at Lambda School, making at least $50,000 a year or more. So it's pretty risk-free, other than the time you spend, of course. But so what does a day at Lambda School look like? Well, you're in class, depending on your time zone, the time changes, but you're in class from 8 a.m. Pacific to about 5 p.m. Pacific. The morning is spent on instruction. So you actually wake up and the first thing you do a code challenge. And that code challenge looks a little bit like some of the problems you've seen in the homework for this course. It's meant to get your brain warmed up, to get you thinking about code and thinking about how to solve problems and to learn new skills. And then you spend the next two hours or so from 9 a.m. to 11 Pacific doing the main lesson for the day. So you learn, the new concepts for that day. And typically for the iOS course, that's going to be, stuff that's directly related to building apps. And you're going to actually write a lot of code and use Xcode and learn all that stuff. Then lunch, and then for the afternoon, you spend that working on a project. And that's an assigned project. Again, sort of like the homework you've seen in this course, although it tends to be a lot more extensive, because instead of working on it for an hour, you're working on it for maybe 3 hours. And during that entire time, you have help from PMs and instructors, so that you're not just struggling on your own, trying to figure things out and getting stuck. When you get stuck, you have somebody that can help you. And then you finish up the day with basically what we call code review. It's where you meet with your PM to kind of go over what you did that day and have questions answered, and get feedback and give feedback. And so it's a pretty structured course, and you get a lot of guidance through it. So instead of just trying to learn on your own, you have experts that are helping you. We have a cohort starting on July 16th. And the cool thing is that this iOS 101 course is, of course, free for everyone. We want everyone that wants to take it, and a lot of you already are. But it also basically serves as the pre-course work for our full-time course. So if you finish this course and do well, you can expect that you know what you need to know to start the full-time course. You're already basically prepared for it. If that's something you're interested in, you can apply on Lambda's website, and please feel free to ask me any questions. DM me on Slack if you've got questions about the full-time course. I'm happy to answer them. This is the main thing I actually work on in my day job is the full-time course that's coming up. I'm really excited for it to start. I'm going to be teaching every day for the first cohort, and we've got a team that I think is incredible. I'm really proud of the people that we're putting together. So anyway, that's kind of a little bit more about our full-time course. Let's dive in and start talking about some Swift. So we're actually going to mostly talk about strings today. We're going to talk a little bit of Xcode stuff. But let's start by talking about strings. So I think the first question is, what is a string? And a string is very simply a list of characters. It's some text in order. So a word is a string. It's just a bunch of letters in a certain order. A sentence is also a string. Basically, any text that might go in your app is a string. And of course, if you think about the apps that you've used, every single one of them has text on screen. It allows you to type in text into, with the keyboard. It allows you to receive text, sometimes to edit text. So text is something, strings are just something you can't get away from. You're going to use them in every app you ever write. And you've actually already seen a little bit of them in the stuff you've done in this 101 course, because we just kind of can't avoid them. So even though we hadn't had a whole lesson on them, we knew you were going to have to use them and sort of taught you the basics. But we're going to dive a little bit deeper today. And the very first thing we're going to talk about is what's called a string literal. So what is a string literal? What does that really mean? Well, a string literal is the way you put a string in your code. So I'm going to switch to the screen share and show you a playground. I'm being probably overly optimistic about playgrounds again today, but hopefully this works well. All right. So here's a playground. And actually, if you create a new playground, you have this var str, which is short for string, equals hello playground. This is actually a string literal. So a string literal in Swift is any string that goes in between two quotes, two sets of double quotes. Why do we call it a string literal? Well, I'm not really sure, except to say that literals are any values that get included directly in your code. So if we do let a equals 42, this number 42 right here is a literal. That means that it's not something that the program calculated. It's something that is directly included as a number in our source code. And so we have literals for numbers. That's an integer literal. We can create a floating point literal by doing something with a decimal point. That's a floating point literal. We also have Boolean literals, which is just true or false. True is a Boolean literal. It literally means true. So strings also have literals. This is the way we include a string directly in our code. Instead of having our program, compute or create or calculate this string, we can include it directly. So you use string literals all the time, because a lot of the static text that's going to appear in your user interface is going to be a string literal, and you use them for lots of other things too. So to recap, a string literal is a string that is directly included in your source code instead of being something the program calculates. And to create a string literal, you just surround the text you want to be in the string with double quotes. Anytime you do that, you've got a string literal. And you can use this anywhere a string is required. So you can pass this into a function that takes a string. You can assign it to a variable, and this is now a string. And there are lots of things you can do with strings. So that's cool. Now, what about if I want a string literal that spans more than one line? Turns out you can't just put a new line in here. We can't just say there's stuff on a new line, because string literals have to be on one line. And you see it says error unterminated string literal, meaning you started a string literal with this open quote, but I never saw the closing quote. And yes, it's right here, but it has to be on the same line. So that's a problem. What if we want a string that spans multiple lines? Well, that's a common enough thing that there's another kind of string literal called a multi-line string literal. And a multi-line string literal is just what it sounds like. It's a string literal with multiple lines. So how do we do that? Let's call this multi-line. To create a multi-line string literal, you start with 3 double quotes in a row. And then you go to the next line, and here's where your text goes. And then on its own line at the end, you put 3 more double quotes. And now it is important that the opening double quotes are followed directly by a new line. And then at the end of the string, you start a new line before you do the closing double, the 3 closing double quotes. You can't put these on the same line. That won't work. This first new line gets stripped out, and so does the last one. So if we print this now on the playground, sure enough, it spans 3 lines. So multi-line string literals are nice if you just need to put a bunch of text in a literal and have it span multiple lines. You don't use them all the time, but they come up often enough that it's good to know about them and how to use them. All right, so let's move on to another thing that's interesting in string literals, and that's something called an escape character. So there are some characters that you can't directly put in a string. We've already looked at one of these. If I create a string and I don't want to use it, sometimes you may not want to use a multi-line string literal, but you may want to put a new line in other words, a break or a carriage return on one line. Well, you can't just hit return in your string. That won't work. So we want this, but we want this second sentence on its own line. You can't just hit enter. We could do that with a multi-line string literal, but not with a regular one. So there's an escape sequence. It's a special sequence of characters that represents something that we couldn't otherwise type. So for new line, it's actually \n, and that means instead of \n, when the compiler sees this, it goes, oh, what that really means is go to the next line. So if we print this, you'll see that sure enough, they're on separate lines. So there are some other ones, and the curriculum for this day, the written lesson stuff on learn.lambdaschool.com has a table of all of them. But another important one that comes up a lot is double quote. What if we want to say, we want a quotation in our string? Well, we can't do that because Swift sees this first quote and thinks that it's the closing quote for this one. And this is not inside a string. We've got 2 more quotes. It's all messed up, right? And it's because a double quote means something specific to the compiler. It means here's where the string starts and here's where it ends. But what if we actually want a double quote? Well, there's an escape sequence for that. You just put a / in front of the quote that you want to literally include in the string. It'll work. So now we can print this. You see it actually has quotes in the output. You use that / quote for a double quote. And same goes for single quote. You can do single quotes with / single quote. And there are some others. You can add tab characters. You can add, what if you want a \? Well, since \ starts an escape sequence, you just do / something. This won't actually work. Say invalid escape sequence in literal, because it sees the / and then it thinks you must be trying to type \s. Well, that doesn't mean anything. So instead, you have to do 2 \, which means an actual \, and that works. So go look at the table in the curriculum if you want a complete list of these. But I think quotes and new lines are the ones that you actually end up using the most. Okay, so let's have everybody follow along. We're going to write something using a simple string literal, and we want it to print the boy cried wolf. I'll type it out here. So we want to print the boy cried wolf just like this, with this on its own line and then this one 2 lines later. We're going to do this with a regular string literal first. Let's say let phrase equals open quote, and the boy cried. And how do we go to the next line here? Well, we do that with a new line character, a new line escape character, and that is \n. And then we actually need another one because we want to go down 1 more line. So we'll do another one, \n. All right, now there's something interesting here again because we have quotes around wolf, and we can't just type a quote or it won't work. Instead, we need to do \quote. By the way, the \, if you're on a US keyboard, the character is the one that's directly above the return key. If you're on a non-US keyboard, it might be somewhere else. I'm not actually sure, but it's the one that slants from the left to the right as it goes down. So we do \quote, and then wolf, and then another \quote, right, to cover this. And finally, a last quote, which is the closing double quote mark for the entire string literal. And let's print this and see if it works. And sure enough, it worked perfectly. So make sure you can do that. It's a little bit weird, right? Because you start having to figure out how to read these \n, \/ quote, and all this stuff. But with some time and some practice, this doesn't look quite as scary as it does when you first see it. Okay, so let's move on. Another thing we're going to talk about today is concatenation with strings in Swift. I think most of you have also already run into this because it was in the homework. You were supposed to stick some strings together, take two strings and basically smash them together to make a new string. And we call that concatenation. Concatenation just means taking one string and then sticking another string on the end of it to make a new one. And you can actually concatenate more than just two strings. You just can keep concatenating multiple strings into one. So the easy example of this is if we have one string called hello, or with the value hello, and then another variable or constant with the value there. We want to stick these together to make one string that says hello there. You can say let greeting equals string 1. And then we actually use plus. With numbers, plus, of course, means add these two things together. When you use plus with strings, it means concatenate these two things together. Conceptually, it's sort of similar to adding two things together. But we might actually call this instead of calling this the addition operator, for strings, we would call it the concatenation operator. So we need a space in between them. So we'll concatenate a string with just a single space in it. And then we'll add on the second string. And now if we print greeting, we should get the entire string that says hello there with a space in the middle. And we've managed to take two strings plus a space and combine them all into one. So that's string concatenation. It's pretty simple. I'm guessing that most of you are not shocked to learn this. There are actually several other more powerful ways to combine strings, and we're actually going to talk about one of those today. But this is pretty simple and useful, and you'll end up using it a lot in your Swift. Okay, so we're going to change gears just a little bit. We're still talking about strings. As always, if there are any questions, I would like for you to post questions in the iOS June 11 Slack, and I'll watch that, and I'm happy to answer them. Let's move on to the next thing in strings. Well, we already said at the beginning that a string is really just a list of characters in order. So if you want to do something with each character in a string, and a character is just a letter or a number, it's just a single, this is the equivalent of a single letter or punctuation mark or number or whatever, or emoji for that matter. That's a character. If you want to do something with each character in a string, you can actually use a for-in loop to go through each character in the string. So if we have a string called where with the value hello, actually use a for loop. We can say for character in string. This will just loop through the entire string, and for each iteration of the loop, character will be set to that character. And we'll just print these to see what happens. What do you think will happen? What do you think this will output? Well, I think every time this runs, character is going to be the next character in the string, starting at the beginning and going to the end. And since print prints out whatever you pass it on its own line, I think we'll see HELLO each on its own line. So I'm going to run it. And sure enough, that's what we see. Now, of course, that's a really simple example. I used print just to show you how this works. But you could do anything you wanted in here. Any kind of processing where you need to go through each character in order, you could do with a for loop. So let's follow along again. Let's have you guys follow along. We're going to write a function. Func. We're going to call it number of A's. So this function is going to take a string as an argument. and it's going to count up the number of A's in that string. So it'll take a string as an argument and count up the number of letter A's in that string, and then return an int that is the number of A's in that string. And I'm going to actually use a different external name just so the function reads a little nicer. So how might we do this? There's no built-in function to count the number of A's, so we need to write a little bit of code. Well, we can do this with a for loop, right? We can go through every character in the string, and if it's a letter A, we add one to our running count. So let's create a variable called count, start out at 0, and then we'll write for character in string. This will loop through each character, and we'll check to see if character is equal to A, capital A, or character is equal to lowercase a, because those are actually different, right? The computer doesn't know that lowercase a and capital A are, to us, both A's. We need to check them both. If it's either an A or an uppercase A or a lowercase a, then we'll go ahead and add one to our count. And we can add one to an integer variable by saying count plus equals 1. It's actually shorthand for saying count equals count plus 1. So take the current value of count, add 1 to it, and then assign that as the new value of count. But we can write it like this. This is fine, but doing plus equals 1 is just shorthand for that. It means take the current value of count, add 1 to it, and then assign the new value back to count. And after we've gone through the whole loop, we'll just return count. So write this out, and let's call it. Let's see what it does. So I'm going to say print number of A's in my name, Andrew Madsen. Of course, this should be 2. There's a capital A at the beginning and a lowercase a here. Sure enough, it counted 2. So try it out with a string, maybe your name, or just whatever you want. See if it comes up with the right answer. I can just put in a bunch of A's, right? It should count all of them. And that looks right. So there you go. There's a really simple use for loop that iterates through every character in a string. And you may think this is a little silly, and it is, of course. It's not that often that you would need a function whose only purpose was to count the number of A's in a string. But things like this, where you go through an entire string and perform some sort of analysis of the characters in the string, are relatively common. It's not something you never do. Okay, so the challenge is that I'll give you, basically 5 or 10 minutes for, is to make this take another string. You can actually make it take a character. Number, we'll make this say of character. Let's call this C. Number of character in string. So now instead of it only counting A's, you can pass any character you want in, and it will count the number of that character. And don't worry about dealing with uppercase and lowercase for this one. If you pass in an uppercase A, it should just count the number of uppercase A's. It would be significantly more work to have it take in an uppercase A, figure out how to convert that to lowercase, and check both of them. You can do it if you want. That'd be a good stretch thing, but don't worry about that for now. So I should now be able to call this as number of A in, like that. And it should print out 1, right? Because there's 1 capital A in Andrew. I'll let you write that and give you 5 minutes, and then we'll check back in. And in the meantime, if you have any questions, post in the iOS June 11 Slack channel, and I will be happy to answer. Okay, so Leo has a question. What does of and in mean? This was covered in Thursday's lesson, the last lesson. So if you want to go a little deeper, you might look at the curriculum for that, or watch the video. But when you create a function, you can give each argument, which is the parameters that you pass in, two names. So the first name is what we could call the external name, and this is the name that appears when you call the function. The second name is the internal name. So this is the name of that argument in the implementation of that function. Now, I haven't implemented this function yet, but if I wanted to refer to C, the character that's passed in for the first argument in the code in the function, I would use C. You don't have to provide two. If we just use one, then the internal and external names are the same. We would have to change this to C. So why would you have two different names? Why not always use the same one? Well, it's because if we call this of, that's a weird thing to refer to it as in the function, right? What is it? Of is not even a noun, so it would not make the code inside the function read very naturally. It would be hard to understand. On the other hand, if we make this C, well, that also doesn't really make any sense. So number of A in Andrew makes a lot more sense than number C A string Andrew. On the other hand, inside of this function, we want to call this a string and this C, which is short for character. So that's why I've given these separate internal and external names. There's no rule about when to do this, and I think probably on average, most functions are, most arguments just have one name that's the same for both external and internal. But if it will make your code read nicer, you shouldn't be afraid to use separate names. And so that's what I've done. I hope that answers your question, Leo. Is that satisfying? All right, so I think I know it's not been quite 5 minutes, but that I think that's probably long enough. So let's just go through this really quick. How would I do that? Well, I still want my count variable, and I'm still going to iterate through each character in the string. I need to delete that. But instead of checking to see if it's equal to A, I should say instead, if character equals C, then add 1 to my count. That's all. And it worked. It says 1. And if I add, some extra lowercase a's, it should not count those, right? Because now it will care if it's capital or lowercase. And sure enough, it doesn't. But if I add some extra uppercase a's, it does count those. So it's doing just what we expected. All right. So we have one last thing to talk about with strings before we move into some Xcode stuff. And we're going to talk about something called string interpolation. We've had at least one bonus problem that used string interpolation. So I know many of you did some research and figured it out on your own and used it in your homework. But here we're gonna cover it for real. So string interpolation is a fancy word for saying I want to make a string that includes the value of a constant or variable from my program. So let's say we have a constant called number of cows. And we want to create a string that says the farmer has, however many cows they have, cows. So we could do that using concatenation, kind of, right? We could say string to print equals the farmer has plus, well, how do we turn the number of cows into a string? Well, one way we can do it is actually to call the string initializer, which we'll talk about initializers in more detail tomorrow. But we could call the string initializer and pass in number of cows. This will turn the integer of number of cows into a string plus. This actually works. This is okay. Worked. It's a little wordy. And it has another flaw, which is that you can't numbers you can pass into this string, but there are other types of values that you can't convert them to a string just by saying string parentheses number of cows. There's a more universal solution that I think is a little nicer called string interpolation. With string interpolation, instead of using concatenation and the plus sign, we say, I want to stick number of cows right in my string here. And the way you do that is you surround it with parentheses preceded by a backslash. So backslash, open parentheses, the name of the constant or variable, and then close parentheses. And we say cows. Now this is all just one string. And interpolation means when it sees backslash parentheses and then something inside, the compiler goes, oh, that's not a, that's another constant or variable, a string maybe, or a number or some other type. I'm going to go get the value of that, turn it into a string, and then stick it right there. And we should get the same result. And sure enough, we do. So this is pretty nice because it makes it so that you can create strings that include text that came from somewhere else in your program. It's kind of like combining a string literal with a string that is computed or calculated when the program is running. Okay, so let's do something a little more complicated. Let's all follow along. We're going to write a function. We're going to call this function print formula for multiplying. It's going to take an A and a B, and it's going to return, or it's not going to return anything, it'll just print. So if we call this with print formula for multiplying, say 2 and 3, what we want it to print out is 2 times 3 equals 6. So kind of like the way you would say the whole equation and the answer. We can do that with string interpolation. All we have to do is say print backslash parenthesis A times backslash parenthesis B equals backslash parenthesis A plus B. Sorry, not A plus B, A times B. Now when the compiler sees this, it'll see this and say, oh, I need to get the value of A, stick that in here. Get the value of B, stick that in here. And you can actually put a whole expression in there. So it doesn't just have to be the name of a variable. It can be anything that will evaluate to something that can be in the string. So it sees this and goes, oh, first I need to multiply A times B, and then take the result of that, turn it into a string, and then stick it right here in the string. So that's string interpolation, and it works. And we can try this with other numbers besides 2 and 3, say 7 and 13. And it works. All right. Okay, so that is all we're going to talk about with strings today. Now, there's more to know about strings, and you'll learn more as you go along. But those are sort of the most important things, the things that you're going to run into the earliest and the most often. Creating strings with string literal syntax, concatenating strings with the plus sign, looping through characters in a string using a for loop, and using string interpolation to include the value of other things, variables or expressions or constants in your strings. We're going to switch gears now, and we're going to talk about something in Xcode that we haven't gotten to yet. And you're going to need it for your project today. So I'm going to create a new project in Xcode. I'm going to choose single view app like we usually do. And I'm going to call this outlets because we're going to learn about outlets. Okay, so one of the things we saw before is that if you put a button on your screen like this, and you want that button to do something when it's tapped, you have to create an IB action. The IB action is what happens. It's a function that gets called when the button is tapped. So, oops, you can do that by right-click dragging or holding down the control key and then left-click dragging from the button to your code here. And selecting action and then saying, calling this button was tapped. Of course, we can just print something. Work. You've all done this now several times, so it should be getting pretty familiar to you. But this is only really one piece of the puzzle, one side of the equation. This allows a thing on screen, a button. It works for other things besides just buttons, including text views and sliders and other things, to tell the view controller when the user does something. So when the user taps a button or enters some new text or moves the slider, it allows that UI element, user interface element, to notify the view controller that has happened by running a function. So let's add a text field. A text field is just a box where a user can type some text. And let's say we want, I'm going to stretch it out a little. Let's say we want, when the button is tapped, we want our app to get the text that was typed in to the text field and print that out instead. Well, here we have a problem, right? Because how do we get the text out of this text field? We can't say let text equals text field dot something. That doesn't work. There is nothing called text field here. We try to build it, it'll say use of unresolved identifier text field. So some way we need to give the view controller a way to access the things that are on the screen. And we do that using an outlet. So just like an action is a thing that allows the button to talk to the view controller, to access the view controller, an outlet allows the view controller to access something on the screen. And you create it the same way. You control drag from the element that you want to connect to over into your view controller. In this case, I'm doing it from the text field. And then you let go, and instead you choose outlet for the connection, which is probably the default for all of you. Then you give the outlet a name, so I'm going to call it text field. You can call it whatever you want, and hit connect. And this creates what's called an IB outlet. It's basically, don't worry about the weak, we can actually take that out. You'll learn what weak means later if you took the full-time course. But it means create a variable called text field that's part of the view controller, and it's connected to the text field. So now we can say let text equals text field.text. Now this variable will include whatever is in the text field. I build, sure enough, it's fine now. This warning just says you didn't use that thing you created. If I option click on this, though, you might notice that it's a string optional. That's because what if they haven't typed anything in the text field? What if they've left it blank? Well, then it doesn't have a value, so the value is nil. So we actually need to unwrap this. We can say if let text equals text field.text, and assuming it's not nil, print the text out to the console. So we can do that, and this should work. Let's try it. I'm going to select these and add missing constraints like we usually do. Now I'm going to run it. Okay, now if I tap the button right now, nothing should happen, right? It just doesn't do anything because there's no text in the text field. If I type something into the text field and then tap the button, it prints out whatever I typed in the text field. So that's cool, I guess. The outlet gives us a way to access our text field. All right. Well, that's great. I want to show you something else here that you haven't seen yet. That's something called a guard statement. So we can do this. We can use if let. We can type a bunch of other stuff here, more code here, and then maybe we might have to do another if let because we have another optional. And we do more here, and so on. And this happens in real code. You end up having to unwrap lots of optionals in a row, and with doing stuff in between, and your code gets more and more indented. And we actually say that this is shaped like a pyramid because it's like a triangle here, like a sideways pyramid. And Swift programmers call this the pyramid of doom. That's half joke, half technical term. And so it can make your code kind of hard to read. It's kind of hard to follow because you keep having to parse out these if statements and you have to look way down to find out where they end. And it's not very nice. So to avoid the pyramid of doom, we have something called a guard statement. A guard statement is kind of like an if statement turned inside out. So with an if statement, we say, check to see if textfield.text is nil. Not nil. If it has a value, assign that value to text and then run the stuff inside the if block. A guard statement, on the other hand, would be written by saying guard let text equals text field dot text, and then an else statement. And you notice there is no statement before the else. You don't do that with a guard. So this says let text equals text field dot text. If text field dot text is nil, then run the else statement. And we're going to say return, meaning just quit the function, stop running. And now after the guard statement, text is available and it's not an optional. Now we can write our code like this, and we don't get this pyramid of doom. We check to make sure that textfield.text is not nil first, and if it is nil, then just bail out. We're basically guarding against the case where it's nil, so that everything else in our function here, everything after the guard statement, can assume that it's not nil. It will know that it's not nil without having to be inside of an if clause that makes the pyramid of doom happen. But you'll see these a lot. That's all that means. It means first check to make sure this is not nil, and if it is nil, then bail out because there's nothing else we can do. Guard statements are interesting that way. You actually can't not put a return there. If I don't put a return there, it'll say guard body must not fall through. Consider using a return or throw to exit the scope. And we haven't talked about throws, but it does a similar thing to return. It just says bail out, get rid of the get out of this function because we can't do anything. That's the guard statement. So we've got an outlet to our text field and a button and a button with an action, and the outlet allows us to access our text field and grab the text from it, and then we print it. We're just going to take this one step further to practice with outlets. So I'm going to add a label. A label is kind of like a text field, except that it doesn't allow the user to type in it. Instead, it displays text that the program determines, but you can't type into it. So I need to create an outlet to my label, and I'm going to do that by, again, right-click dragging, and I'm going to call this label. Don't worry about the weak. It's fine if you leave it there, but don't worry about understanding that. You'll learn about that later. Now, instead of printing to the console, I just want to make the label say whatever was typed into the text field. So I can do that by saying label dot text equals text. This takes whatever was in the text field's text that got assigned to this variable and puts it into the label. And now if we run this, that's what we thought. Sorry, I haven't been paying good attention to Slack. Lotana, I hope that's how you say your name. You asked, how come when you write a function with no return, Xcode screams at you? It should only scream at you if you do say that the function returns a value and you forget to actually return a value from it. As long as you don't have a return type, meaning the function doesn't return anything, it should not require you to have a return statement. If you're having a problem with that, you might want to send in your small group, I would say post your code and we can help figure out what's going on. Okay, so this actually ran shorter than I expected, but that's good because it gives you time for the project. And I'm gonna explain the project and then basically just turn you loose if there aren't any questions. So the project today is called Palindromes. Let me bring up the page. And it's meant to practice strings and also using outlets in Xcode in an iOS app. So this helps you practice that stuff, but it's kind of a fun little app. It's going to have a text field and a button. And when you enter some text in the text field, and then you tap the button, and if the text you entered is a palindrome, it should say such and such string is a palindrome. I just realized there's a typo in the README. Let me just fix that really quick. All right, so it should say string, this meaning the thing that the user entered into the text field is a palindrome. And if it's not a palindrome, it should say, string is not a palindrome. I should have actually added that. And for anyone that doesn't know, a palindrome is a word or phrase that's the same whether you spell it forwards or backwards. So like the word madam is M-A-D-A-M forward. It's also M-A-D-A-M backward. And a race car is another example of that. But it doesn't just have to be a single word. It could be an entire sentence. That's what a palindrome is. So go ahead and create this. There are two bonus questions. And I think the first one is something that a lot of you should try. I think as many of you as finish this project should try the first bonus problem. The bonus problem is make it so that it ignores capitalization and punctuation when checking to see if a string is a palindrome. So for example, was it a car or a cat I saw? Question mark. Isn't exactly a palindrome because there's a question mark at the end, but not the beginning. And also the last W here is lowercase while the first W is uppercase. But normally when we're talking about palindromes, we ignore that. So we just ignore the question mark and ignore the fact that there's differences in case and check it anyway. So this should be considered a palindrome. Now, and the same is true, by the way, with the I and the I here for capital versus lowercase. Now, one thing that I should probably be, I'll update the README to be more explicit, is that even in your first version, you should ignore spaces. So spaces should not matter. If somebody enters a complete sentence, you should ignore the spaces. Otherwise, lots of things that should be considered palindromes won't. This is another example of that, right? Was it a car? And if you read it backwards, it's was I T A C and then a space. Like this is it. This is its own word. Car is split with spaces. So you need to get rid of those spaces to ignore them. There are multiple ways you could do this. I kind of expect a lot of you to do it with a for loop, but that's not the only way to do it. And one thing that is probably good to know is that you can use this string.reversed to flip a string around and make it a reversed version of itself. So that might help you. As always, if you have questions, please post them on Slack, reach out to your PMs and get help. And I want to once again encourage all of you to join if you're watching this live, to join your discussion groups in the third hour on Zoom. If your discussion group seems sparsely populated, maybe like you're the only one there, maybe reach out to your PM and see if you can be put in another group for the night. And if you're watching this after the live stream doing the self-paced option, remember that while you don't have a live group discussion, you can post questions in iOS after hours on Slack, and you should be submitting your homework to your PM. And last but not least, I want to remind you all that tomorrow we're not going to be doing this on Slack. We're going to be using Zoom. So there will be a link dropped for you, if it hasn't already been, to sign up for a Zoom webinar. And you all should go do that before tomorrow, so you're ready to go when we start. So, all right. Thanks everybody so much for watching. I'm enjoying this. I hope you're enjoying too. And I'm excited to see you tomorrow. Bye.